Hi there everybody, my name is Jeremy Krug and I'd like to welcome you to another chemistry video. In this video we're going to be starting a series of lessons about electrons in atoms. Now electrons are very important to us because that's where chemical reactions take place, that's where the chemistry is actually happening in the electron. It's very important that we talk about electrons before we start moving into things like chemical compounds and chemical reactions. Now in this video, we're going to learn some of the basics behind how electrons are configured in atoms. And we're going to use a model called the Scandium model of electron configurations in order to help us learn this. Now this is a model that I developed around the year 2001, and it's been effective in teaching lots of students how to write and talk about electron configurations. Now I should warn you, this method is a little bit corny, but if you play along, by the end of this video, you should have a pretty good idea as to how electrons are configured in atoms. Now the way this works is we have this model that looks like a stadium. You see we have some sort of a playing field or something down here in the middle, and then we have these levels of seats. The first level, the second level, the third level, and the fourth, and so on. And as elements enter our stadium, we want to assign them the best seat possible in our stadium. And so we're going to talk about how those electrons are assigned and configured in this video. Now, as we talk about this stadium model, I should let you know that atoms don't actually look like this. An atom does not look like a stadium. This is just a model to help us understand some things. Like a lot of scientific models, this stadium model is designed to help us understand how electrons are configured. So don't think that an atom actually looks like this. Now, the first element that we're going to talk about is hydrogen. That's the very first element on the periodic table. And I have a little periodic table here as we work through this so you can follow the elements on the periodic table as they come into our stadium. So hydrogen wants to have the best seat available. Well, I see a really good seat right here next to the playing field in level 1, section S. And so I'm going to put an arrow right there to represent where hydrogen is sitting in the stadium. And we're going to write down its ticket stub. And so hydrogen's ticket stub is going to say that it is sitting in level 1, section S, seat number 1. So I'm going to write 1S1. Level 1, section S, seat number 1. Now, let's take a look at the next element that comes into our stadium, which is helium. Now, helium, as you can see, is the next element, and it also wants to have the best seat available in the stadium. And I see a really good seat right next to hydrogen right here. So I'm going to put an arrow right next to hydrogen to show where helium is going to sit. Now, I know that arrow is pointing in the opposite direction. We'll talk more about why that is later, but let's just live with that for now. So helium's ticket stub is going to say that it's sitting in level 1, section S, seat number 2. And so its ticket stub says 1S2. And so that's what we have there for helium. Now, let's try our next element. And so lithium, as we can see on the periodic table, is the next element that enters our stadium. And lithium wants to have the best seat available as well. But I noticed that the first level is completely filled. It only had the S section there, and it looks like each box only holds 2 seats. And so the first level is filled. So it's going to have to go up to the second level. Now, notice in the second level, we have S and P sections. So which one is it going to sit in? Well, lithium sits in the S section because those seats are special. You see, the P seats are kind of pricey. I told you this was a little bit corny, right? So we're going to put lithium in the special seats right there. And so we're going to write its ticket stub. Now, I should let you know that lithium's ticket stub, and really all these ticket stubs, are not just going to say where lithium is sitting, it's also going to mention all the other sections that are occupied. So lithium's ticket stub is going to say that level 1, section S, has 2 seats in it, and it's sitting in level 2, section S, seat number 1. And so here's its ticket stub, 1S2, 2S1. Now let's try the next element that comes into our stadium, which is beryllium. Now beryllium wants to have the best available seat as well, and I see a nice seat right here next to lithium. So I'm going to put it right there, and on its ticket stub, it's going to say that level 1, section S, has 2 seats occupied, and it's sitting in level 2, section S, seat number 2. So there is the ticket stub for beryllium. Now, the next element that comes into our stadium is boron. And boron wants to have the best seat available, but as you can see, there's no more room in the S section. So boron's going to have to sit in those pricey seats in the P section. So there's boron's seat. I have a little arrow for that. And so its ticket stub, just like all the others, is going to mention all the sections that are occupied. So boron's ticket stub is going to say that level 1, section S, has 2 seats filled. Level 2, section S, has 2 seats filled. And it's sitting in level 2, section P, seat number 1. So it ends with 2P1. Now let's try the next element. The next element is carbon. Now, where do you think carbon is going to sit? Well, you might think it would sit right next to boron there, but as it turns out, carbon actually sits in the next box over, right there. Now you might wonder, why is that? Well, these elements like to have a little bit of elbow room whenever they're in the stadium, just like a lot of people do. Let's say that you go to a movie theater and you're the first person in that theater. This is a movie that you've been wanting to see for a long time. So you have your popcorn, you have your soda, and you sit in the best seat available. And then a couple of minutes later, a total stranger walks in, and this theater is completely empty, and they sit down right next to you. How would you feel about that? For most of us, that's a little bit uncomfortable, isn't it? You see, people like to have a little bit of elbow room if they can. Well, these elements are kind of like that way too. They like to have a little bit of elbow room. Now, if the stadium starts to fill up, they'll sit next to somebody else if they have to, but they like to start out with a little bit of space. So that's why carbon is going to sit right here in that next box. Now, its ticket stub says that level 1, section S, has 2 seats filled. Level 2, section S, has 2 seats filled. And it's sitting in level 2, section P, and it's the second occupied seat right there. So it ends with 2P2. I told you this was a little corny, right? But if you follow along, you hopefully will get the pattern here. Let's take a look at the next element, which is nitrogen. And it's going to do the same thing as oxygen did. He likes to have a little bit of elbow room. So nitrogen is going to sit in that next box over right over here. So I'm going to put nitrogen there. And its ticket stub says that level 1, section S, has 2 seats filled. Level 2, section S, has 2 seats filled. And level 2, section P, well, it's the third. So it's 2P3 is how that one is going to end. Now, let's try oxygen. That's the next element. Now, you might see that there are no more empty boxes in the P section. So these boxes are starting to fill up, so now they don't have any other choice than to sit next to somebody. So oxygen is going to sit right next to, I think that was boron over there, so I'll put oxygen right here, and its ticket stub is going to say 1s2, 2s2, 2p4, because we're in level 2, section P, and the 4th seat to be filled there. Now, you might notice that we're starting to have a little pattern here. We had 2P1, 2P2, 2P3, and now we have 2P4. Maybe you can guess what the next one is going to be, right? Let's take a look at fluorine. So fluorine is going to sit right in that second box there. So I'm going to put fluorine right here. And its ticket stub is going to say 1s2, 2s2, 2p5, because it's in level 2, section P, seat number 5. So yeah, the pattern is holding, isn't it? Let's take a look at neon, the next element. We can see where neon is on the periodic table here. It's going to sit right there. It's going to fill up that P section. And so its ticket stub is going to say 1s2, 2s2, 2p6, because we're in level 2, section P, seat number 6. Now, since only 2 elements or 2 arrows can fit in each box, that tells us that the 2p section is now full, isn't it? So as we start the next element here, which is sodium, Na, where is it going to have to sit? Well, it's going to have to hike up to that 3rd level of the stadium, isn't it? And so once again, we have S, we have P, we have a D section this time. Which section is it going to sit in? Well, we said that the special seats get filled up first, don't they? Those are special. The P seats are kind of pricey, so they get filled up a little bit later. So S is where sodium is going to sit, right there. So its ticket stub is going to say 1s2, 2s2, 2p6, and it's sitting in level 3, section S, seat number 1. So there's the ticket stub for sodium. Now the next element that comes into our stadium is magnesium. We can see that's the next element on the periodic table here. And it's going to sit in that special section of seats right next to sodium, isn't it? So magnesium goes right here. Notice its arrow is going in the other direction, just like we had for the others. And so its ticket stub will say 1s2, 2s2, 2p6, and it's sitting in level 3, section S, seat number 2. So there's the ticket stub for magnesium. Now, the next element on our periodic table is aluminum. That's what's going to come into our stadium next. And which section is going to be filled? Because the S section is filled. Well, it's the P section. Those seats are pricier, so they get filled second. So we're going to put aluminum right here as the first element in that 3p section. So aluminum's ticket stub is going to say 1s2, 2s2, 2p6, 3s2, and it's sitting in level 3, section P, seat number 1. So hopefully you can see that pattern is starting to emerge again. Now the next element is silicon, and silicon is going to sit in that next box over, just like we had in the last level of seats. You know, these elements like to have a little bit of elbow room. We'll talk more about that here in a future video. So its ticket stub is going to be 1s2, 2s2, 2p6, 3s2, and it's sitting in level 3, section P, and it's the second occupied seat, so 3p2. So once again, we had 3p1 in the last one. Silicon has 3p2. Maybe you can guess what the next one's going to be. Our next element is phosphorus. And so just like you might have guessed, phosphorus is going to sit in this next box over right here to occupy that empty box there. And so the ticket stub for phosphorus is going to say 1s2, 2s2, 2p6, 3s2, and we're in level 3, section P, seat number 3 to be occupied there. And so that is the ticket stub for phosphorus. Now the next element is sulfur. Now notice all 3 of the boxes in the 3p section have an arrow in there. So where is sulfur going to have to sit? Well, it's going to have to sit next to somebody, right? So we're going to put sulfur in that first box right here for 3p. So its ticket stub is going to be 1s2, 2s2, 2p6, 3s2, and 3p4, because we're in level 3, section P, seat number 4. Now the next element that comes into our stadium is chlorine. You can see we're slowly progressing, aren't we? These are slowly getting longer. So chlorine is going to have to sit in the next box, next to whatever element that was. So we'll put chlorine right here, and its ticket stub is 1s2, 2s2, 2p6, 3s2, and 3p5, because we're in level 3, section P, seat number 5. There are 5 elements in 3p. Now, the next element is argon. And where do you think argon is going to sit? Well, there's a nice seat for it right here in that third box of the 3p section, isn't there? So we're going to stick it right there. And so argon is going to be 1s2, 2s2, 2p6, 3s2, and 3p6 right there, because it's in level 3, section P, seat number 6. So now it looks like the 3p section is filled, isn't it? So no more space there. So the next element that comes into our stadium is potassium. Now, where do you think potassium is going to sit? Well, you might think the 3D section, because that seems to be next. However, it doesn't get to sit there. And the reason is that the D seats, the D section, is reserved for the deserving. I told you this was corny, right? So guess what? Potassium doesn't get to sit in the D section because it's not deserving. So guess what? It's going to have to hike all the way up to the nosebleed section here and sit in the 4th level of that stadium in the special seats, in the S section. So potassium goes right here. So can you write the ticket stub for potassium from the beginning? Well, let's see here. What's occupying our stadium? We have 1s2, 2s has 2, 2p has 6, 3s has 2, 3p has 6, and now we're in level 4, section S, seat number 1. So it ends with 4s1. Let's try the next element, which is calcium. Now, calcium's not deserving either. So where do you think calcium's going to sit? Well, in that 4s section, isn't it? Right along with potassium, right here. So what's its ticket stub going to be? Well, it's 1s2, 2s2, 2p6, and then 3s2, 3p6, and now we're in level 4, section S, seat number 2. Okay? Notice these ticket stubs, or electron configurations as they're correctly called, are getting longer and longer, aren't they? They're going to get a lot longer too as we do elements that are farther down the periodic table. Let's try the next element, which is scandium. Now you might notice if you look at the periodic table here that scandium is the very first transition metal on the periodic table. Well, guess what that means? That means it's deserving. So it actually gets to sit down there in the 3D section. So I'm going to put scandium right here, since it gets to sit in the 3D section. And let's write out its ticket stub from the beginning. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and it's sitting in level 3, section D, seat number 1. So it ends with 3D1. That's the electron configuration, or the ticket stub as we're calling it, for scandium. Now let's try the next one, which is titanium. Now it's a transition element too, so guess what? It gets to sit in the 3D section right along with scandium. Now it likes to have some elbow room just like those others, so titanium is going to sit in the next box over, right there. And so titanium's ticket stub is going to say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and where is it sitting? It's in level 3, section D. It's the second occupied seat, so it's 3d2. Now, let's do one more, and then we'll stop for this video. We'll take a look at the next element, which is vanadium, which, by the way, rhymes with stadium. So it's a good one to end with, right? So where is vanadium going to sit in the stadium here? Well, in the next box over, isn't it? Right here in that third box, just over from where titanium was. So let's see if we can figure out vanadium's electron configuration, its ticket stub from the beginning. Can you do that? We have 1s has 2, 2s has 2, 2p has 6, and then 3s has 2, 3p has 6, and then 4s has 2, and finally we're in level 3, section D, seat number 3. in that section, so it's 3d3. So that's the ticket stub, or the electron configuration for vanadium. So these are getting longer, aren't they? What we've just done is we've written the electron configurations for the first 23 elements on the periodic table. I have vanadium covered up, but we saw that on the last slide. Now, in our next video, we're going to take these electron configurations and we're going to try to find some more patterns. Maybe we can find an even simpler way than the stadium diagram to write these electron configurations. Now, we are going to use that stadium diagram for something else later, but we'll talk about that coming up. So once again, this is a simple way to learn how electrons are configured in atoms and how we place electrons into something we call orbitals and sublevels, which we'll talk about in a future video. Hey, thanks for watching. I hope you learned something from this video. Hope you enjoyed it. If you did, please consider slamming that thumbs up button, and I'll see you in the next video.